So, hello everyone. My name is Chris, and I'm going to talk a bit about GNU Guix. Just as a quick survey, how many people have heard of GNU Guix before FOSDEM? Why am I even here? Oh, that's like most people. Okay. So I found out about GNU Guix back, not the last FOSDEM, but the one before, back in 2016. I remember installing it the night before, which is, yeah, how I can remember about it. So some of the concepts involved in Guix take a bit of time to get used to. So I've tried to break down the benefits and properties into three different areas, kind of dependability, flexibility, and Guix's position as a general purpose package manager. So starting with dependability, I consider Guix to be very dependable. The main building block for that dependability is the immutable store. So the store is a directory where data can be added, but it can't be changed. With Guix, the location for that is kind of fixed, so it's at /GNU/store. When you build packages with Guix, you can fix the behavior of those packages at the build time, so it doesn't change later on when you're using it on different systems. I'll give some concrete examples of how to do this later on. The other part of dependability is kind of coping with inevitable failures. So sometimes things go wrong, and the best thing to do is just go back to when it was working before you did anything. And the architecture Guix uses kind of elegantly supports that. So having spent a couple of years now doing odd things with Guix, I can say for sure that it's quite a flexible tool. Guix supports downloading packages like binary packages from the internet. It also supports building those same packages from source. That building from source can come in really useful when you're building your own packages or tweaking the definitions for ones you already have. Guix also elegantly supports building, like having multiple versions of the same package, and having multiple versions of the same package even on the same system. You can even have multiple different variants of a single version of a single bit of software, perhaps built with different compile time arguments. Finally, Guix is a general purpose package manager. Personally, this is something I have a big preference for. I think the kind of problems of package management are best tackled without fracturing the effort along lines like programming language or fields of use. While Guix is a general purpose package manager, though, it has specific tooling. So if you want a Docker image, for example, there are ways of getting from Guix to that. Guix as a package manager, because of this, works on many systems. So you can use it on Debian, but also there is a system called GuixSD, which is built around Guix itself. So it kind of goes across that traditional boundary between package managers linked to an operating system and other package managers. Right, on to some practical stuff. You might be able to guess what this command does. It will look at the available packages, find one called hello, and then install it to the current user's profile. In case you haven't encountered hello, its purpose is pretty simple. Provides a binary called hello that prints out hello world when you run it. The profile bit is key here, and I'll try and explain this now. So let's take another example. Say you've installed two packages, SamTools and Bowtie. You would end up with something that looks like this. So you have a .guix profile symlink shown at the top in your home directory. It would point at another symlink in the /var/Guix directory. That symlink would then point at another symlink named with a number, and that symlink would then point into the store. So it's a directory ending in -profile in the GNU/store directory. The number of the symlink here, 42, is the generation of the profile. So it's your kind of 42nd version of your profile. The profile directory doesn't actually store the files for those packages. It's just linking to those files in the packages in the store. And all this complexity is actually hidden from the user. If you run the Guix package command, you'll usually just get the environment variable set up for you to use the packages you've installed. So here the path will be set up to include the profile, and that would put, I mean, you can use SAMtools and bin bowtie too. So what happens if you make a change? Say you remove the bowtie package, so just like you can do -- install, you can do Guix package -r and then the package you want to remove. So a new generation of your profile will be created. So there's a 43 that's appeared, and the symlinks are now linking through that to the store. The directory in the store for the profile at the bottom here has been updated. It no longer contains the bowtie 2 package. It's just pointing at the SAMtools package. The critical thing that's happened here, or rather not happened, is you still have your old profile. You still have all the stuff you had before, you're just not using it anymore. What this allows you to do is to roll back. So you can just switch back to using your 42nd generation of your profile, and you're back with the same things you had before. Because the store's immutable, you know that this is the same stuff. It can't have changed. So yeah, to recap, the immutable nature of the store combined with the way we're using profiles here means like you've got that dependability. Even if stuff goes wrong, you can roll back. So on to some flexibility now. So the Guix package command deals with profiles, but there's another command that also does that as well, the Guix environment command. The purpose of this command is to create development environments. So you want to work on a package, but you don't want to install all the dependencies using the Guix package command. So you can run Guix environment hello, and it will set you up with an environment which contains the things you need to build that. So like GCC in this case. So if you were to run that command, look at your find GCC on your path, you'd see it appearing off the end of the screen here. So looking past the purpose of the Guix environment command, it's a very flexible way of dealing with like arbitrary profiles. So here's how you would generate a profile containing the hello package and the guile package. If you were to look at the profile in the store, you'd see something like this. So we're looking here at the bin directory of that profile, and it's composing those two packages by symlinking to the files in the bin directories of those two packages. So to recap very quickly, installing packages to your user's profile, you can do by Guix package-i. Entering a development environment, you can use the Guix environment command. And to enter an environment with like specific packages, you can use the --add--hoc flag to the Guix environment command. Right, let's look at some more interesting ways of using Guix packages. So usually Guix packages explicitly rely on the dependencies by pointing them where they lie in the store. So this is really useful for reliability. Because the store is immutable, if you're pointing at something in it, you hope that it doesn't, with some degree of reliability that's not going to change. So the behavior of your package is kind of on that stable bedrock. It also provides some flexibility because as you know what's used, you can remove all the unnecessary stuff around the side. So this is what this command does. Now the bash shell started in this environment will be started in an isolated mount namespace with only access to the parts of the store it needs, some certain bits of the root file system and your current working directory. It's also in a different PID namespace and several other namespaces. So if you were to look at, say, the contents of your store, you only see what you need for running hello here and bash. You also don't have like ls, so hence why you have to use echo. So note here that I'm not talking about kind of containers I am talking about containers in the sense of just Linux namespaces. So like somehow the term containers has kind of been conflated with managing state and package management. So Guix you've got some separation between these two concepts. You've got the information about what's using what at the package manager level, and that enables you to kind of add on some container stuff on top. So this is another way of looking at that information. So here's a graph generated with Guix for the hello package. It shows the references of that package and the things that you're referencing, their references as well. So this, along with another command called Guix size, can be really useful in understanding kind of what this graph looks like in the store. So this, if you actually look at what those references mean, one of the references that the hello package has is in the way the binary is linking to the shared libraries it uses. So you might not be able to read this very well because the text is quite small. But on the left here we have calling the LDD command on the hello binary in the store. And it's printing out these long paths to show which shared libraries it's referencing. And it's referencing them by their absolute location in the store. Now this gives you some reliability, as like the hello binary won't change in its behavior, or at least not from these things changing, because they're not going to change, they're in the store. So this is a concrete example of how you fix the behavior of a program at build time. So you build it to use these exact shared libraries, and then that won't change even if you deploy it to a different system. One thing, so this you might know of static linking and dynamic linking. I mean, this is a kind of like hybrid approach where you're doing dynamic linking, but you're getting some of the benefits, some of the stability from static linking. It's quite cool. So back to some flexibility. So we looked at Guix package -- install. You can tell it to use a different profile. So say if having one profile per user, which is how Guix works by default, isn't enough, you can have arbitrary numbers of profiles. What that will do is it will create some symlinks where you put the profile, so here in the current directory, that point to the relevant bits in the store. Another neat way that I've come to use Guix is to integrate it with a program called direnv. So direnv is a completely different thing. It's an environment switcher for your shell. So you can write a file called .envarc, put it in a directory, and when you enter that directory, direnv will kind of evaluate that file and set up your environment, make some changes to it. You can get Guix to say which environment variables you need to change to activate a profile. So you can hook the two things together by putting something like this in your .envarc file. So use Guix --adhoc GCC toolchain Python LXML, and that means, so I've put this in the temp foo directory so that when I enter it, Guix finds out what environment variables I need to change to use these, and then direnv will adjust the environment to match. So this is quite a cool way of kind of managing dependencies on your system. You kind of just change into the directory and you get GCC appearing or Python appearing. Okay, another cool thing. So Guix pack is really practical, offering some of the benefits of kind of bundling software together, but also using Guix at the same time. So some quick examples. Here, packing up Guile, Emacs, and Geyser, so into a tarball that contains not only those packages, but also all of their indirect and direct dependencies in the store. You can also generate a tarball that's kind of a format compatible with Docker using the same approach. You just add -f docker onto the command. Right. Guix has around 6,500, possibly more, packages, but you might want to use something that's missing. One thing you could do is look at packaging it. So Guix contains several importers, so programs that can use existing metadata, say on sites like PyPI for Python or rubygems.org for Ruby, and create a package definition using that information. Now, depending on the importer and depending on how complete the information is that it has available, you might get a package that builds, or you might need to do some tweaks. But they're a very quick way, importers are a very quick way of building packages. So that's kind of readable. Here is an example package definition. So this is for the hello package that we looked at earlier. It's pretty simple. It's not it's literally just this bit of code. You don't have multiple files. The entire build process is encapsulated into the build system, which is around the middle kind of the definition. But this is a simple example of something that kind of follows some conventions. Guix is like for some stuff's more complicated, and you have to build more complicated package definitions to handle that. Now, one part of why Guix packages are so dependable is what this kind of represents. Even though we're not declaring any additional inputs beyond what the build system provides, this package represents kind of all of that information. So, as well as the source table, so the source table is kind of a bit towards the top. What I'm getting towards is that you can pull out that information and graph it, which gives you something like this. So, this is a representation of that package. Here we're graphing the derivations for the package. I don't expect you to read this, but I've coloured some of the parts differently. So if you noticed the source for hello has this kind of hash in the bottom represented in base 32. That means it's fixed data going into this kind of process. So the fixed data parts of this process are coloured in black, and they kind of lie around the edge, as you'd expect. The bits coloured in purple towards the middle are the derivations. So the bits of the process in building hello that take some data or some output, some other derivations, combine it together to build something. So hello is one of these purple nodes towards the left, I think. Now, you might have noticed in some of the examples I had earlier that there was a hash showing up. So that hash represents this graph, all the bits of data that are going into it. That means if you change any part of this graph, the hash will change and the package will be different. This is how you kind of get different packages for different build steps. The hash describes all parts of the process, so if you change a single part of the process, you get a different hash, a different entry in the store. Right, so thank you for listening. I intentionally I think we're doing very well on time. I didn't put any demos in, but I'm quite open for going back and trying to look at some of the things in more specifics. This was kind of before using Guix for a couple of years now, I was quite familiar with doing Debian package things, and it took me at least a year to come around to the idea that this was kind of even sensible. So it's not something I'm expecting to convince anyone kind of overnight, but if you want to talk to other people, there's a quite active RC channel on Freenode. And there are blog posts and mailing lists on the website. There's also a talk, a couple of talks actually, in the HPC track tomorrow, including one by Ludovic Cortez, who kind of started the Guix project. Any questions? Hello.
Does Guix have any means of kind of clearing up old packages so that if you install something large like TechLive, every time you get a new version it doesn't go through the process?
Yes, so the question was, does Guix have some way of clearing out old packages? And the answer is yes. So in the same way that, actually I had a example, actually no, I didn't have an example for this. So there's a command called Guix GC, which is aptly named garbage collector. It works in the same way as you might be familiar with garbage collectors from like programming languages. You have a graph, the graph of items in the store, which have kind of dependencies on each other. You can start at the like known kind of roots, the generations of your profile, the other bits of software that are installed on your system. You can find everything that is used in the store, and then you can cut out everything else and get rid of it. And that's a really, really safe process because you've got those absolute dependency links. You can remove stuff without worrying about someone using it, providing they've kind of registered their use for it, which like commands like Guix package and Guix environment make easy to do. So yes, it does. You yeah, you can get quite big stuff, and especially on small systems, you can run out of space, but you can work out what's taking up your space and get rid of it from the store. Hello.
2 questions.
Yes.
Okay. I'll do both together.
Yep.
And you answer them. I have my own particular software that I'm trying to package for HPC purposes, and so package management is always an issue.
Mm-hmm.
Currently directly supporting the SPAC because it works for us. Easy to build is a bit of an issue still, but what I want to be able to do is to build my version of software with different variants.
Mm-hmm.
You know, to build a version which has, say, 32-bit labels, integers, 64-bit floats, or 32-bit floats, with a particular version of Boost, with a different version of Seagull, with an older version of Flex, and have like 6 different combinations coexisting to be able to swap them.
Yeah.
Second part of the question is, I'd like to have this deployed in such a way that you can say, this is going to be my installation path, and then make that available on, say, well, generally available for everybody on the cluster, and not one machine, but say, whatever, 5,000, 10,000 cores, something like that, where not everyone is going to have Guix installed there, but then I'd like to then wrap it with a module system to then address what's going on. Could any of this fit with Guix?
Yeah, so to summarize, two questions. First, variants. Secondly, cluster deployments. So I don't personally use any HPC stuff. Maybe some of the people who do, because I know they're in the room, can join in afterwards. But yes, variants are a possible thing. So I was in the SPAC talk earlier, so I know, well, what was said in that talk about variants. And Guix has some... You can add some things on the command line for rewriting the kind of the directed acyclic graph for packages, but that sounds like it might not be quite sufficient for your case. I mean, but you've still got, you can write out the package definitions and write out some functions to make the transformations you want to, and that it should all be possible, including, yeah, using multiple versions of things and managing it elegantly. The second part about profiles deploying this, yeah. So it sounds to me like the Guix kind of package command where you tell it to use a profile, that might fit conveniently. You can have a name for that collection of software that you've kind of curated, and you can put that somewhere on the system, and then a user can source the /etc/profile file within that, and that will set up the whole environment.
Could I load that up as a TCL or a Lua module?
So could you load that up as a TCL or a Lua module? So so could you have a Lua module within that profile which you load up using Lua, or?
I don't care what it's called, you just have to work with what other people are using, which is modules.
I'm not familiar very much with the modules thing for HPC, but like if you wanted to, if you had Lua software in that profile, then that should work. If you had a Lua program to load that profile, then that should work as well.
Later.
Yeah.
To this question if you want, because I do it with Nix, not Guix.
Mm-hmm.
You can generate module with it. You can use it as a specific language and generate HPC module out of any Guix or Nix package as well.
Cool. So I'll repeat your answer. I think that was someone uses Nix, which is very similar to Guix, and it's possible with Nix. So yes. Yeah. Yeah.
Thank you.
Cool. Yeah.
Among the distributions that I can use Guix on top of, is one of them on Windows?
So I don't know of it working, but I know that there's the bash or kind of GNU-like thing on Windows. I guess it should work. I mean, you might have some issues with getting the build daemon to work, because the build daemon uses like namespaces, which are, well, Linux namespaces. So you'd have to see how well Windows' kind of kernel supports those, but to do the isolation. But maybe if you, like maybe, yeah, it might be a question of how many compromises you make.
But, so do you know of anyone in the Guix community that has tried to run the package management on top of
Not sure if I repeated the question, but yeah, this is about Windows, and no, I don't know of anyone who's tried it, but yeah.
I've tried Nix on Windows with Bash, like you said, and it worked.
Cool.
With recent recent updates of Windows 10, because with the first one, they were not the right system call.
I'm not asking because I want to use Windows, but because if I adopt something and then I have users using Windows that want
Yeah.
to use it, then
Right, so the answer was with recent versions of Windows, Nix works, so that should be good. Right, I think time's up. So I have some stickers if people want stickers, and you can come and ask me questions afterwards as well. Yeah.
Anyone got